Alright guys, here's the homework help video to kind of help you through the ones that most people had questions on. I think I'm doing 2, 6, 7, 9, and 10, and they're in order. So if you don't need this one, if you kind of scroll ahead, you'll be able to get to the one you need. So when we look at number 2, we definitely want to be working on the left side because it has more information. And I'm specifically looking at anything I could do to the top here. So that says 1 minus sine squared theta. So when I look over here, I'm looking at this one because this is the one that has sine squared in it. You have one of two options. Those of you that are really liking just the replace what I know part, you can say the 1 is going to turn into sine squared x plus cosine squared x. You could also manipulate this right now and subtract the sine squared. And if I were to take the sine squared and move it over here and subtract, it would be equal to cosine squared. So either way, I'm going to do this the long way. But realize those of you that like the shortcut, you can do the shortcut. So I'm going to replace the 1 with sine squared plus cosine squared. And then it's minus sine squared on top still over cosine theta. And we want that to equal cosine theta at the end. So then what happens here is these cancel. And we end up with cosine squared theta over cosine. And I don't think we've seen one like this yet, but what's happening here, it's like having x squared over x. If I have x squared over x, one of the x's can cancel with the squared and it's just x. If that doesn't make sense, you could write cosine squared as cosine times itself. So if we write that out, then you're going to see that one of them cancels, but one of them stays behind. So it's pretty much just the squared that was canceling up here before with the bottom. But if that doesn't make sense, you can always write it out separately and cancel it. So now we got cosine theta equals cosine theta. Check. All right, let's take a look at number 6 next. All right, the key to number 6 is really looking at which side to start with here, because technically both sides have the same amount of information, but the fact that this one has two different things, that's kind of the one that I'm looking at more, because if I can take this thing that has two different things and make it so they're both sine squared, that's going to help me to get closer to that left side, or to the right side. So I'm going to start on the left side. And specifically the part I need to swap out is I need to swap out what cosine squared equals. So for that one, you are going to have to take this equation, you're going to have to manipulate it. So I'm going to take that equation, sine squared plus cosine squared equals 1, and I'm going to figure out what cosine squared equals by subtracting sine squared. I know cosine squared x is equal to 1 minus sine squared x. That's where we're going to plug in. We're going to take that, I'm going to plug it in here. So it's going to be 1 minus sine squared x equals 1 minus 2 sine squared x. And then the key to this one is that we have 2 sine squared x's. When you add 2 sine squared x's, you get 2 sine squared x. And that is what we wanted it to match. So I've gotten it to match. So I'm done. Check. Alright, number 7 next. Number 7, when you look at this one, we definitely want to FOIL, which I think most people got to that step okay, I would think. It's 1 for the first, the outside is minus cosine theta, the inside is plus secant theta, and then the end is minus secant theta cosine theta. And our goal is get that equals secant theta minus cosine theta. So here's the tricky part here, is we kind of get stuck for a minute. So then whenever I get stuck, my thought is, can I change everything to sines and cosines? Which you have to be careful with this one, because we still do want a secant in our answer here, so we don't want to change them all out. Specifically this one here, if I were to try and change that, it's not going to help me simplify anything because this is a plus sign. Things don't cancel. You can't cross cancel like this when it's a plus sign. It doesn't work like that. It only works when you're multiplying. So I'm going to take that away. The place that that's actually going to help us is the place where it is being multiplied here. If I switch that out, so I'm going to just keep all of this the same, 1 minus cosine theta plus secant theta. minus, I'm going to switch that out. I'm going to make that 1 over cosine theta. So it's in terms of cosines and sines, and this is going to stay cosine over 1. And our goal is to get that equal to secant theta minus cosine theta. And now because these are multiplying, they cancel. So I have 1 minus cosine theta plus secant theta. That's minus 1 left. It doesn't completely cancel. There's still a 1 there. Equals secant theta minus cosine theta. And now hopefully you're starting to see where it's going to go. These are going to cancel out. And then if I just reorder this side, it really is secant theta minus cosine theta. That's why we wanted to leave this one alone. We didn't want to change it so that we get it to match the right side like we wanted to. Check. All right, number 9. We have lots of foiling to do here. So reminder, when we're squaring something, that means we need to multiply it by itself. So this is really sine x plus cosine x times sine x plus cosine x. Plus, then we have to do the same thing with this one. Sine x minus cosine x times, move this guy out of the way. Whoops. Sine x minus cosine x. And somehow this all is supposed to just equal 2, which is kind of crazy to think about right now. But let's start foiling. Sine x times sine x is sine squared x plus sine x cosine x plus sine x cosine x plus cosine squared x. Then we FOIL the other part, so then it's going to be, I have to write this down here, plus sine squared x minus sine x cosine x minus sine x cosine x plus cosine squared x. So then if we look at what cancels here, this actually cancels with this from the red one, and the red one and the blue one cancel there too. So what we're left with is sine squared x plus cosine squared x, and another sine squared x plus cosine squared x. It's supposed to equal 2. Well, if you pay any attention, this is that basic one. Sine squared plus cosine squared. That actually, I like when I see that. That's actually really, really awesome because that whole thing just changes into 1. So this is going to turn into a 1 plus, same thing happens here with that one. That turns into a 1. That's supposed to equal 2, and guess what? 1 plus 1 is 2. So we got it. All right, last one. This is number 10. So this is one, again, you need to look and figure out which side is going to be easier to manipulate. You could try working through the left side. There is a way to get the answer with the left side. I kind of am more in tune with the right side, just because it has more math in it. It has a plus or minus sign, so I'm kind of more focused on that side, but you can pick. You could actually, I had seen someone that had asked a question about this, and they worked both sides out. And you can do that. You just have to make sure you're not moving things from one side to the other. We're not allowed to move from one side to the other, but if you get stuck in a problem and you need to try to work the other side to get them to match at the end, you could. But I'm going to try and work the right side all the way out. So that says 1 minus cosine squared. So I'm thinking over here of looking at this guy right here. I'm going to do this again the long way, is I know what 1 equals. 1 is equal to sine squared x plus cosine squared x. So I'm changing the 1 into that, and then I still have minus cosine squared x over cosine. And that's supposed to equal sine x tangent x. So then things do cancel here. The cosines cancel. So I end up with just sine squared x over cosine x, and that's supposed to equal sine x and tangent x, which we're not quite there yet. So this is where I suggest taking this and we can break it apart, just like I had done on the first problem, is when it's squared, that's really just 2 of them. So if I make it sine x times sine x over cosine x, we're getting closer because now we have one of the sin x's here. And if you look at, we can take this and pull it apart. And if I look at my plate, I know sin x over cosine x is, in fact, hopefully you said tangent x. So left side is supposed to be sin x times tangent x, and now the right side, I got the sin x here still, and that part I circled in red does turn into tangent x. And I get them to match. Check. So you're allowed to do that. You're allowed to pull apart the squared part into two separate things and then separate because it's all in one fraction. You can choose which one to group it with. If you're adding and subtracting, that would be a different story, but because we're multiplying, we're allowed to kind of group them however we want. Alright, I hope this helps, guys, and I will do this again with the assignment for over the weekend. If you post by Sunday night where you have questions, I will work through those problems, and I will do the same thing with a video to help you to make sure that you're understanding the ones you have questions on. Good luck, and I will see you everybody on Tuesday.